So what I have in front of me here is this component right here. This is actually the breathing valve, and it's a one-way breathing valve. The white plastic part is the intake valve. So when a client breathes in, it breathes in only the room air, and then when he expires, the air goes out through the clear outtake valve and into the hose. Now, what you can see inside of this, two rubber gaskets that ensure one-way breathing, so that when the client breathes in, only room air is coming in, and when he exhales, that all the air is leaving into the tube. None of it escapes back into the environment. Okay, and then the part that's connected to this device here is that's actually the mouthpiece where the client would breathe into. Now, this long cylinder syringe is it's a calibration device. So with each plunge of the syringe, it pumps in 3 liters of air, and that is used to calibrate the device down here that we see. The white component with the hoses coming out of it, that is called a flow meter, so that it precisely measures the amount of air that is passing through it. So if I know the amount of oxygen that's in the air, and I know how much air the client is breathing in, and I know the difference between the oxygen that's in the air and the expired air of the client, the difference represents what's being utilized in terms of oxygen and what's being produced in terms of carbon dioxide. Okay, and then the gas tank over here is used to calibrate the oxygen analyzers and the carbon dioxide analyzers. So on the back side, if I show you this over here, you can see there's a clear rubber tube that goes into it. That's the calibration gases, and then there's also a kind of an open gasket there that sucks in room air. So what it does is it sucks in room air, sucks in calibration gases, and just calibrates the oxygen analyzers and carbon dioxide analyzers based on known gases. So that's very accurate and reliable. Now, during the test, as the client breathes out, all the air ends up in this clear ceramic box. It's called the mixing chamber, and it just mixes the gases. And then periodically here, we get the oxygen analyzer and carbon dioxide analyzer would sample the gases, suck it through, go into the machine, and basically analyze it for its oxygen carbon dioxide concentration. Okay? And so that all happens automatically. It's an automated process. Very little has to be done on my part for that. With the computer. So there is a feed that comes from that oxygen analyzer to the computer through this USB over here, and then it just that data is collected, and I'm able to know what's being utilized for oxygen, what's being produced in terms of carbon dioxide. And once I know those two values, then there's some calculations that we can do to see what you're utilizing for fuels, whether it's protein or, rather it's carbohydrate or fat. We can also look at the amount of oxygen that you're consuming relative to the work rate, so we can get a measure of efficiency, how efficient you are in using oxygen and producing energy. So very useful device, very good for endurance athletes and ultra endurance athletes.